Okay, and number 7, I just want to go through some messier examples where we have definite integrals and we're trying to use substitution. So we got all the pieces. I absolutely encourage you to pause and try to do this yourself and then check and see if you got it right. And if you didn't, you can watch what I do and see where you're going wrong. But there's nothing new I have to say here. I just want to put it all together for you. Okay, so it is a definite integral. There is some kind of weird product going on. We're going to learn integration by parts shortly, which also deals with products, but we're specifically looking for chain rule type things. So pieces I see here, remember that when stuff is in the bottom, it's really 1 over. So this is really like having a 1 over x and a 1 over ln x dx. You don't have to rewrite it that way, but I think the reason that this type of problem is tricky for people is because they're thinking about that as just an x and an ln x and not a 1 over. So the composition I see is here. I have a reciprocal function, a 1 over x type function, with a natural log plugged into it. So I'm tempted to say that the inner function there is w equals natural log of x. And I like it as I get into it because that would mean that dw dx is 1 over x, and I have one of those floating around as well. So I can say dw is 1 over x dx, and that means that I can take this pair right here and I can replace it by dw, and then I can take this right here and replace it by w, and I get 1 over w dw. Okay, so in that first step, all I did was rewrite. I didn't change variables, so my limits of integration should still be 1 and e. On this step, if you write 1 and e, this is where you're lying a bit. This is where I said earlier you're kind of lying or contradicting yourself, because as soon as this is a dw, these are automatically assumed to be w values. So right now, if I write 1 to e, I'm saying w goes from 1 to e, and that is wrong. So even though you can do kind of a 2 wrongs makes a right in these problems, don't. I want to see you actually do it the right way where your limits change in this step. So to change my limits, I'm just going to go back to my formula that tells me the relationship between w's and x's, and I'm going to say, okay, well then when x is 1, the natural log of 1 is 0, so w is 0. And when x is e, the natural log of e is 1, so w is 1. So now I'm not lying. Those truly are w values. I can go ahead and say 1 over w's antiderivative is natural log of absolute value of w. And you don't ever, I don't need that plus c, you don't ever need to switch back to x's with definite integrals because we've already changed to w values. So at this point, we'll just, oh, I made bad limits of integration. Did I really? I think I did. We'll make it natural log of 1 minus natural log of 0. And this is bad news. This is 0, just to mention it. Natural log of 1 is 0. But it's not such great news. This is actually what you'd call an improper integral, so my bad, don't worry about it. We will do them shortly, but we have some asymptotic behavior that we're integrating up to. Natural log has an asymptote at 0, so those are actually fascinating. I really like them, but we're not there yet. So let's just say teacher made a bad limit of integration. And I guess I can even see it back here, right? If you plug 1 in, natural log of 1 is 0, so you're dividing by 0. So my bad on the endpoints, but that is the right idea. Change endpoints and then plug in. Can't say for now. Okay, so let's do one more, hopefully with good limits of integration. In fact, definitely, because